Fine. So like I want this session to be as much interactive as possible. Okay. So ask questions. So no question is right and no question is wrong. Okay. So let's discuss it. As many questions as possible. Okay. So yeah. So those who know, like, can you guys see my screen now? The like the whiteboard over here.
Yes, sir. It's visible.
Yeah. Very good. So okay. What exactly is machine learning? So from here, we'll start maybe for 15-20 minutes. We'll understand what it is. Like, let us clear off all the myth involved, and then we'll go ahead like with our coding. So what is machine learning? So anybody could explain it? Even in the chat, I'm fine. Even if it is in the chat. What is machine learning? A simple question. Okay, so give the machine data as input so that it can give desired output. Prediction of the process with which we train a machine to learn, training the machine to do work for the machines which can't be done by us. Okay, good. So these are like now multiple examples or other multiple answers we could get. Fine. Helping machine to learn its own to master a particular task. Okay. Use math and data to predict the input output. Okay. Fair enough. Applying algorithm and data to find a pattern in it, which is useful to predict unseen data. Beautiful. Good. So machine learning is method of data analysis that automates analytical model. Okay, fine. So sometimes okay, I'm too old to really get all these jargons into my head now, and hence maybe I'll stick to the simple wordings and I will make it the definition are very simplistic. Okay. So even before that, I'll ask them. I have a question to you guys. So the question here is like, what is the difference? All these days we were doing this, right? So whatever you are saying, like the complex data analysis, everything. So we were doing this, right? Even without machine learning. So we were using programs, computer programs, right? From the days of C, C++, or Pascal, or Fortran, or Lotus, or today you have Java, and again when you go to web, you have HTML, JavaScript, whatnot, right? We were actually doing similar stuff, right? And why at all we require machine learning then? What is the difference between this programming, hardcore programming, and machine learning as such? What exactly do you think is the difference? Automatic. Okay. We give data and instructions to computer and tell what to do. In ML, we help machines to learn what to do. Okay. ML can learn by itself without being explicitly programmed once we provide some initial data. Fine. Not sure if this is right, but in ML, we optimize the data and reduce redundancy. Okay. That's a nice assumption. We don't have to make change in the code if there is change in input data in ML. Okay. Fine. So beautiful answers. Fine. Machine learning is that programming aims to answer a problem using a predefined set of rules or logic. Fair enough. See, let's, okay, which one is more effective? Machine learning or programming? Let's say I have a situation, fine, a sales prediction. Let's say what we are going to do today. Fine. So which one is going to be effective? Machine learning? Machine learning. Sure. Okay. Okay. Programming. Fine. Good to see contrary answers. Okay, program. Fine. Depends on situation. That's more diplomatic. Both go hand in hand. Okay. Different areas of application. Fine. Okay. So here, let me start off why it all machine learning rather than pure coding. Fine. So as you guys, like most of you know, like most of the answers what I have got. So simple programming, obviously, like, so what had happened is, yes, we were doing something called hard coding, okay, and pure logic, fine. So we were like actually doing all this logical stuff. So actually this one is more ideal, given any situation. Programming is more ideal. Okay, let me tell you that. Okay. So the simple reason is, yes, let's say, let me give you an example and from there we'll talk. Okay, something related to today's one. Let's say I have a cluster of customers. Okay, a customer in some zone, let's say in Bangalore or Chennai. Okay. So let's say this is Bangalore, and let's have some subclusters. Clusters in the sense, yes, people belonging to this area, they buy a particular product more, okay, than people over here. Okay, so let's say this is the idea behind clustering. Okay, let's say this area, they are actually buying more products. Fine. So with programming also I can find out this. And also one more thing is, with programming I can even understand like who is this customer, and again like I can offer some promotional activities in this area. I can run some promotional activities in this area, and I can be more successful than putting the same efforts over here, right? So this I can do even with programming. But the problem comes when the actual area changes, right? Or like the people they are not buying any such product now. Let's say Nokia was very famous when I started my career. Okay, so in 2003, fine. Nokia phones are very famous, and we thought, okay, wow, like this is the end of technology. So what kind of phone we have got? Just for 1,000 rupees, 2,000 rupees, we have, I know, everything in our hand. Okay, now where is Nokia? We don't have it, right? Maybe yes, in some parts, that's all. But yeah, so this is how people change, the psychology change, the technology. So the business environment also keeps changing. So when it keeps changing, the change is so drastic. Okay, so earlier the change was not so drastic, in the sense any change, like whatever it took 10 years, let's say from 2003, okay, from 2000 to 2010, whatever it took, the same change is happening between 2010 to 2015, the same change, 2017, let's say, the same change within like 1 year. The change zone, it has actually reduced, or it is coming, or it is getting shrink. Okay. So the more the more it gets shrunk, so very difficult it is to rely on program. So programming gives you a very ideal answer. Okay. However, when you come to machine learning as such, machine learning works on only one thing. It never gives you the ideal answer. Let us be very clear. Okay. So do not expect 100% accuracy, perfect answer. Machine learning will not give you that. Let us be very clear. Machine learning is not God. Okay. Machine learning is again human. It understands human and it behaves like a human. So as humans, we err, like we make errors. Machine learning also makes errors. Yes, people do try to fine tune some parameters to see that the machine learning part or the accuracy of machine learning is slightly better than what humans do. Fine. So in case of machine learning, it is nothing but learning from patterns. Okay. Let's say going back to the same example, if I have this cluster, so the pattern is, yes, the people over here, they are buying a lot. Fine. And but the people over here, they are not buying a lot. And hence, this is one pattern. And let's say slowly after 6 months, this pattern shifts to this area. And here people are not buying. Now I'll inquire, like I'll deploy my sales force to see what exactly is happening here that people are not really buying over here. It could be that there is people are shifting from here to here. Okay, this is a more lucrative place now from real estate point of view, and hence they are moving here, and hence this area will be my focus area. Okay, so this pattern, this change in pattern requires machine learning. Fine. So with pattern matching, like I can channelize all my efforts to at the right place at the right cluster. So that's the key idea of machine learning. And okay, so this is one part. Fine. Any questions up to here? so that we can get into the other part of it, the technical part of it. Any questions? Hope you guys got a basic idea of what is this machine learning, its patterns, and again, like machine learning is not 100% accurate, right? It is like human beings. That's a human being that there are no best efforts. That's all, right? Fair enough. So if you have any questions, please do stop me. So I'm all open to discuss. Pattern means, okay, very good. So the pattern, when we say pattern, it's like, let us assume like, there is a, let's say like, I'll take Apple computers, fine. So there, you are setting up you have taken some distributorship or dealership of selling Apple computers. Okay, sorry if you like Apple computers or not, whatever. So I'm taking that as an example, Praveen. Fine. So in Apple computers, like obviously, so you are going to sell MacBooks. Okay. So in this case, let's say like almost you are actually like using machine learning and you are understanding the data patterns in the sense. So you actually track people who come into your shop on daily basis. You collect data about them. Okay, so where are they working? Like so where are they from? Basically, where are they situated? In which company they are working? Fine, all those stuff. Fine. And if you notice that yes, 80% of them they are buying your computers. Let's say out of 1,000 people who come into your shop to inquire about MacBooks, they find it that yeah, you are giving like better promotion and everything, better promotional discounts and everything. But yeah, almost 80% of them they buy. So which is a very good figure for any marketing person. Okay. And but now the question will come, like I want to increase my sales. Let's say this 80% is going to be there for like this 1,000, 80%, 1,000, 80%. If this is going to, so where is the increase? From where the increase will come? So the increase in sales will come from the rest of 20%, the rest 20% people. Fine. Now I will see, okay, fine. See, these 20% people also they belong to the same category. Let's say most of them are working in handsome rather renowned companies with handsome salaries. And these guys are buying 800 people. And why these 200 people are not buying? Though like they meet all other criteria. So this is a typical pattern. Okay. So this is a typical pattern in the sense, yes, 80% will buy, 20% may not buy. Okay. So if I'm going to use Apple computers somewhere in the remote area, remote village, like this may be other way around. Maybe 10% may buy, 90% may not buy. Okay. So like this is again a pattern. So what you will get, right? And all of a sudden, if there is a spike in sales in this particular, let's say in the remote area, remotest part of India or in a particular village, okay. So then there is the pattern is changing. This pattern change programming will not actually accommodate this pattern change. It is very rigid. It is very too good and too rigid, and hence it will not, with the logics or hard coding, you cannot keep changing on daily basis. But in machine learning, as you will find that is this pattern is changing, and you can actually tune the data accordingly, or tune your model accordingly. Got it, Praveen? Praveen. Okay. So hope like you got it. Yeah, very good. So now let's get into the part of it. Cluster. Okay, pattern will change according to the area. Yes, possible. And it may or may not be. We don't know. I have just given you an example. Cluster means like, okay, like it's, how do I say, like it is segregating people according to the same pattern, let's say. Let's say like you guys are interested in machine learning. Let's say I approached 100 people. Fine. So 50 of them joined machine learning and 50 of them, like they said, okay, they will join the next week's course or next week's webinars or whatever. Fine. So you become a cluster for today. So will we receive a recording as well? Like yes, like hopefully yes, you should receive. Fine. Okay, so I'll check with the coordinators also. Okay.
Yes, sir. This video will be uploaded in the YouTube. Nothing to worry about it.
Okay, fantastic. So thanks for it, Raj. Okay, so Rami, you are able to yes, definitely you will receive this recording. Okay, from YouTube. Fair enough. So pattern.
Sorry to interrupt. It will not be uploaded in the YouTube. It will be directly sent to you via mail within 2 days.
Okay, fine. So like yes. So this is this is from the coordinator. Obviously, they have clarified your point, Ramni. Fine. So Garim Sharma, pattern will change according to the area. Yes, so today, let's say some area like before tsunami, let's say that's a beautiful example. So like before tsunami, so the real estate prices were different, in the seashores of Chennai. And all of a sudden, when tsunami came, for the next 1 year, the real estate prices actually went down drastically. Fine. This is change in pattern. Okay. So with how many of us really go to the bank and cut a DD? Nowadays, I don't think any one of you really go to a bank and stand for 2-3 hours and cut a demand draft. I'm not too sure. Okay, because I do not do that for the past 10 years, with this advent of internet and all this internet banking. Right. This is again pattern changing. And again, in the past few years, what happened, what digital revolution? This is again change in pattern. So with us, even not knowing, so the pattern will change, and we are part of the pattern, and we are data points. So let's be very clear. We are data points, and hence we may not be able to see that change in pattern very obviously. Okay. And having said that, yes. So machine learning, the technical part, let's say. So the technical part of machine learning, so how it runs, yes. So normally, as you guys answered, yes, this is something what everyone knows now. So I have some input data, obviously. Okay. So this data, so what will be the timeline to analyze the pattern? It depends on what kind of data you're analyzing. So if you are going to analyze text, that is NLP, when we are talking about natural language processing, so where it finds application in voice to text or text to speech. So all these areas, yes, the pattern change may not be really visible, okay, because it takes a lot of time, okay, for a change in vocabulary, okay. However, in case of sales, it could be so very quick. Or it could, sales of technical products, it is going to be really different, fine. And sales of non-technical products is going to be different. So you really can't say it is going to be 6 months or it is going to be 10 months. Okay, so there will be some difference based on the products what we are talking about, or based on the focus area what we are talking about. Fine. Okay, so coming back to this, technically, yes, you input this data, and again, obviously into the model, and you will get some output, right? Okay. So this is the prediction what you will get out of predictions. Okay. Here input data are realistic data. So realistic input data, let's say. Okay, this you are collected for real. So this is not some dummy data what you are doing it. Okay, yeah. So maybe a few projects you may use realistic or rather dummy data. But in case of real-time applications, you need to go with the right data, not something something what is not going to help you. Okay. So predictions. So input, model, and output. So this is what we know as of now as what exactly is machine learning is all about, right? But yeah, so there are other parts of machine, other parts to it. So this is the most fanciest parts, let's say. Okay, you give input to the model, we talk about algorithms. Okay, see, algorithms don't okay, yeah, knowing about algorithms is really good, but don't really focus on algorithms too much. Okay, the simple reason is algorithms are just you have options. So I have SVM, I have linear regression, I have deep learning. Even in deep learning, you have dense layer, embedded layer. All these you have options you can get it, right? So pick and choose stuff. So, and again, this trial and error, obviously, it will not, it doesn't require much of your, painful efforts, I would say. Okay, it doesn't require the painful efforts from your end. Okay, yes, you need to know how it runs and what is this algorithm, what is linear regression, all this is fine. But there are other areas which require more efforts from your end rather than algorithm. Strictly speaking, like let's say if you are using Google Cloud or AWS, fine. And if you're so sending this input to this particular algorithm, they have all the algorithm built already. You are not going to do anything new there. Fine. So you just input the data, you get the output. Yes, maybe some parameter fine tuning here and there you will do. That's all. Okay. Or otherwise, that is so if you use like say Google Cloud Auto ML or the Text AI, so it's in a jiffy, you will get all the voice to text or dialogue flow and all these things. Maybe in 5 to 10 minutes, you can build your own application. But that is not the idea. So like what goes before algorithm and what comes after algorithm, that is very important. So this is the fanciest part, what we know, normally what we know. Okay. However, there is something before this input, there is something after this input also. Okay. Output. So these two areas you really need to work. Fine. So if you are getting into machine learning, these are the two areas which will definitely help you to really excel in machine learning as such. Okay. So this area is, yes, input pre-processing, I would say. Okay. Or here, I would say output post-processing. These are the two areas you will be recruited for, let me tell you. Okay. So most of the times, it is not for your knowledge in algorithm. Knowledge in algorithm will be part of your interview. Okay, once you get into the company, like nobody cares about that knowledge. Fine. So hardly anyone, because everyone has knowledge today. Okay. But yes, your skill set, you should build your skill set over here and here. Okay. Yes, yeah, Kamal. I'll answer that like along with this. So input pre-processing and output post-processing. Because here what will happen is, yes, all we say, and again, like what we are going to work with is going to be very, simple data structures, simple data is what we are going to work with today. But like if you go to complex projects or even real-time, more business, there is, something which will have more impact on business impact presentations or business impact analysis, there you will not get the right data. First, let us be very clear. Okay. So input pre-processing, you will get dirty data, let me tell you. So this is my naming. Okay. So it is my personal, I love to call that dirty data. Okay. The simple reason is I never get proper data. Okay. So from one single source, like I need to go with multiple sources to get the same data. Right. And dirty data in the sense like the data, what I require is hidden somewhere deep beneath all other data. So everything else is just noise. Fine. So let us say I want to have data on sales. Okay, all sales are rather the product bought by a particular customer. Fine. So the customer, like there could be, I may get the data of some 1,500 customers. Okay, and again, like all those other data, whatever is associated with them, and maybe just beneath all this data, this customer's data will be found. Okay, so this is dirty data, and again from dirty data you make raw data, something what you require, that is you cut the noise and then you create useful data. Okay, and then again this useful data is something what goes into input. Right? And another thing what you need to remember always, sorry, what is Sachin? So we are going to give labeled data. Yeah, labeled data is something, yes, which is useful data. And what is this useful data all about? This useful data is nothing or other. Okay, fine. I got the useful data now, and it has to be like fed as input. Now, this cannot be directly fed to the input because your machine actually it knows only 0 and 1. It doesn't know your like ABCD or like any language. It doesn't know. It cannot recognize your pictures. Okay, it cannot recognize sound. Fine. Everything has to be converted into numericals. Okay, or numbers, or very technically speaking, vectors. You call that as vectors or vectorization. So the mathematics part really actually it comes over here. Any data you have to convert that to mathematical vectors and you input it. The model will work now very fast. Okay, you got the data. So this will always be at luxury. Fine. So if the data is wrong, it will just like throw an error and it will say, like, no, I'm not going to work on this. Fine. And here, once the model actually takes the data, it works and it gives you predictions. So it will also give the predictions as far as it understands, as per the algorithm what we are using. And once you get this particular prediction, now what happens is the post-processing part. Because what you are given as input, numbers, right? What will come out as an output, again numbers. See, what you throw in is what you really get out of it. Okay. And so you give your numbers as input and you will get numbers as output. So there is no change in that. Right? And again, this part has to be converted to, let's say, image or text or whatever it is. Fine. So this part is fairly easy actually. Fine. But yes, this is the area what you really need to focus. And hence, data manipulation is very, very important. I think someone asked, like, where should I start machine learning? You start machine learning with the data manipulation, nothing else. So if you know how to work with data, all these things will fall in place. Fine. If you know how to convert this data and again useful data to vectors, up to here, if you know, so this is almost 80% of your like a machine learning work is done. Fine. And then all you need to do is like you need to connect this to a model and then like you get the output. So this is fairly fine. Okay. So this is like buying groceries. Fine. So modeling and output is like cooking at home and then like consuming. Fine. So buying grocery is a very critical step, right? Okay. Without that, like obviously you cannot cook. The same stuff over here. So the data manipulation, and for that purpose, one good library, what you should use is pandas. Okay. So you should be strong in pandas, and then yes, like you have numericals, and hence you go ahead with the NumPy. Fine. And again, like for visualization purposes, matplotlib. Okay. And all these are libraries of Python. Okay. So do you need to be an expert in Python to really do well in machine learning? Absolutely not. Okay. Even if you are like somewhere between beginner and intermediate, still you can survive in this field. Okay. So yes, knowing Python like to the expert level, it's really good for you, but that doesn't stop you. If you don't know that, that doesn't stop you from becoming an ML engineer. Okay. So as long as you know like a fair bit of Python and then real good knowledge on using these libraries, I think you're doing a good job. Fine. So this is about your machine learning stuff. Okay. And yes, like mathematics part will also come. Yes. In the sense in data manipulations, like here in conversions, you need to know matrices. Okay. And obviously you need to know the probability and statistics. Fine. And again, like here also the matrix knowledge will you need to use. And in model hypertune, that is hyperparameter tuning and all. So you need to have knowledge of calculus, like differentiation and integration stuff, and yes, vector calculus also. So where can you find all this mathematics and stuff? So you can always refer back to your like a 10th standard, 11th standard, 12th standard book. So if you're really strong in those topics of those classes, I think you've already crossed 50 to 60% of the requirement. Fine. So that's the math you require, but you really need to be strong in that. Okay. So this is a fair idea about what is machine learning and where to start and where to go ahead. Okay. So maybe with this, we can start our hands-on for the day. Okay. So any questions up to here? Any questions, guys? So if I have missed anyone's question, please do remind me. So I'll try to answer that also. Any questions? What to do if we have shortage of data? Yeah, so those are yes, shortage of data in the sense you will get least accurate or less accurate, I would say, less accurate predictions. What is hyperparameters? Yes, see, every model has some parameters. Okay, in the sense, let's say, for example, if we are using linear regression, I'll use this equation y equal to x plus b. Fine. And again, this bias, this is called bias. So if I keep changing this using some error function, Obviously, yes, this is one of the hyperparameters. So output processing, okay, output processing actually, there's not much in it. Of course, it is a very important process. Okay, but post processing is you are going to convert numbers to what you really require. Fine, into text, let's say. Fine. Or this will be connected to other text or images. Yes, Yash Sharma, you have raised the hand. What does data manipulation mean? Fantastic question. So data manipulation means like, let's say, I have X and I have Y, right? So what is this Y? So Y is equal to AX plus B. Fine. So Y is dependent on X. So like, I create this data by manipulating X. This is typical data manipulation in the very simplistic terms. Fine. So is there any way to reduce noise in our data? Yes, there are multiple ways to reduce noise in our data, but sometimes you may have to like give away accuracy while reducing noise. So those situations will also come. I mean, do all models try to take time as the mandatory parameter and try to relate change with time? No, not exactly. So, and again, like this time factor, see, actually, like when we say time, this is for our understanding. But again, like if you keep feeding the data continuously, the model will also, the prediction will also keep changing according to the pattern, what is being received. And hence, the model really doesn't worry about the time factor. Yeah, sure, just a moment. Yeah, yes.
Hello.
Yep.
Sir, I want to ask whether can we also, as per the scenario, can we change the algorithms as well? Like not instead of using the traditional algorithms.
Very good. Yes, you can
yes,
do that. You can do that.
But like there are some preset algorithms like SVM, K-means. So
right.
When does that scenario comes in when we play with the algorithms?
Yes.
Or
yes.
change the algorithms?
Yes, you can change the algorithm. So whenever the situation changes, let's say I have a classification problem, and all of a sudden I may have to go for the same situation, I may have to go for regression. The older algorithm will not help. And yes, like you can mix and match algorithm, mix and match hard coding and algorithm. That also you can do. So it's perfectly like flexible enough. So that is what is machine learning. So there is no strict rule. So that is the very basic principle of machine learning. So why it is different from programming? It doesn't follow any rule as such. According to the pattern, it changes. So according to the pattern, if you feel that the algorithm has to be changed, or you need to introduce some hard coding somewhere, yes, you can do that. So it's all, everything is in patches. Okay, so like, yeah. Got it, Yash? Okay, so Jayashree, I think I missed few questions. So Jayashree Varadarajan, how to choose algorithm for prediction? Jayashree, it again depends on like your data and again what type of prediction you are looking for. So there are different types of predictions. Okay, so classic and the key types are classification and regression. Okay, so if you are going for classification, yes, there are a set of algorithms for classification, meant for classification. So yes, it depends on the data and output what you require. And yeah, Pravinian, it means Y depends on the value of X for progress. Yes, like here, whatever we have seen, like Y depends on X for its progress, or rather like, so it is a very simple manipulation. There are other manipulations also, like you do some, obviously like most of you must have used Microsoft Excel. So whatever you do there is data manipulation already. If you are filtering something to find the value of something else, that is data manipulation. And again, if you're like creating a pivot table, that is data manipulation. So what is data manipulation? I want to get some information, some insight from the given data table or data frame, or maybe it could be Excel sheet, okay, or it could be CSV. So that is typical data manipulation, what we are talking about. Okay. And what are X and Y here? Okay, Deepika Narendran, like X and Y here are nothing but the columns are the features. We normally call that as features. Okay, if you have a table and you have like the columns, the column names are X and Y, the column values, whatever you get there. Yes, so that's what we mean by X and Y. Come on, guys, good questions. Any more questions, guys? Anyone? Okay, fair enough. Since there is no question, I think like we are good to go to the next part of it. So I'm stopping sharing. So here I want any one of you to volunteer and share the screen and just follow my instruction, because yes, I can show you like what I'm doing in the coding part and all, but that's not going to help you. Okay, so it will be, you guys will be more spectators. Yeah, Ankit Kumar. Okay. So any volunteers who would like to share the screen? Any volunteers, please? Suresh Sharma. Okay. Just a moment. Thank you, Suresh, for volunteering. Yeah, I can see your screen. Okay. So the first part is, yes, we are going to prepare the data. I have the data already. Fine. So like you are going to prepare the data. Fine. And then we'll start from there. And what is the idea of the project? Maybe like, okay, just give me a few more minutes. I'll share my screen and I'll explain. And then like you can share the screen. So once we get into the coding part. Okay. So sorry if it is inconvenience to you. Okay. So just a moment. Okay. So the data, what is this project all about? This ML project, what we are going to do today. Okay. So this is a very big project for one of the retailers. Like, of course, this is available as a public data set also, but this is this is a real data from one of the retailers. Okay. But I have taken only the small part of it, not everything, because it's very time consuming if you are going to do that. It's a base project at least. Okay. So this small part we will see like how we are going to work ahead with. So first thing is, yes, you are going to prepare the data. So I will show you the data. You just need to like type it and you need to get it in the CSV. Okay. So prepare data and then manipulate the data. Okay. Manipulate data and then fit with the model. So get the predictions. Okay, or understand accuracy. Understand prediction accuracy. Okay. So what is the data we are going to get? So we are going to get a sales data. Fine. So sales data of books, actually book sales. Okay. So this book sales we are going to predict like, or rather we are going to fit with the model. And then we are going to predict whether this model is working. Fine. So this is a simple project what we are going to do. And the data looks something like this. Fine. So here, like before we proceed, we need to convert the data into a CSV file. Okay. So I don't know how many of you really know about CSV files. Okay. However, if you don't know, it's a good opportunity for you to learn it. Okay. So this is a CSV file, what you need to prepare. And then then I will guide you through. So what can be done. So all I want you to do is comma separated files. Yes, very good. So if you know it, it's good. So if you don't know it, it's still good. It won't take more than 5 minutes to really learn this. Okay. So this is the date, paperback, and hardcover. So these are nothing but, so in the book sales data, what we have paperback books and hardcover books. So hardly, if I'm right, some 30, yeah, only 30 data I have taken. Fine. So just prepare this in Google Sheet now. And yeah, once that is done, you can download as CSV. Okay. So download and keep it in your desktop, and then we'll go to the next step. Okay. So hope you can, the numbers are visible to you. Fine. These are realistic numbers, but if you want to like input your own number, let's say, you can do that, but it's always good to go with realistic numbers. So that will help you a lot. So hope it should not take more than 5 to 10 minutes. So finish it fast. All you need to do is like you need to copy this data and then download it as CSV, keep it in your desktop. Fine. So where we can get this file? So you need to prepare this now, Yuvaraj. Okay. So in the sense, open your Google Sheets. So you have my drive. Yeah. So in your Google Sheet, you need to prepare. Okay. So in the same format, there should be date, there should be integers or numbers. Okay. Make it quick, guys. So we start our hands-on from here. No, I didn't send any data yet. I think my screen is visible. You need to type looking at the screen. Yeah, can you repeat what we have to do? Very good. Step 1, open your Google Drive. Step 2, like a new Google Sheet. And step 3, just type the data, whatever you see over here in the Google Sheet. And once that is done, like 31 data are there, 30 data are there, 30 rows, in fact, okay, 30 rows of data and 31 including the headings. And once this part is done, go to the download and download it as .csv. Okay, click it, there will be an automatic download and keep that in your desktop for easy reference. Then we will get into the modeling part. So quick, make it quick, 5 to 10 minutes maximum. Data must be the same as yours. Yes, I prefer that. Okay, I prefer that. So because these are realistic data, and hence let's go with the realistic stuff. Okay. You want numerical columns in the chat? Just a moment. Because the idea is like if you prepare it's. Yeah, sure, Ashin Kumar, just a moment. So side level thing, Bidhi should help you. So the data I have shared now, hope every one of you got it. It's in paperback. Okay. Yeah, Suresh Kumar. Just a minute. Yes, Suresh. Hello, Suresh.
This thing?
Yeah, you raised your hand.
No, that was for screen sharing.
Oh, okay. Just wait for a while. Okay.
Yeah.
So once everyone is done, like we can do the screen share.
Yeah, that was shared and raised earlier.
Sorry.
It was raised earlier, I think.
Oh, achha, okay, fine. Thank you. So on hardcover, so this is the data. Okay. So hope we don't miss anything. Yeah, so I think that could you scroll down some data are not visible. Okay. Hope it should not be a problem now, but still. So just let me know once you are done. Good, Sachin. Good. So Suresh Sharma, you have completed, right? Siya done. Good. Anand Pandian. Yeah, you need to download as CSV. So once this is done, so you need to go here, download as CSV. So you have this option in Google Sheets system. Okay. So the name should be book_sales. The name of the file should be book_sales because we are going to use that in the coding part. So if it is going to be same, it's good for everyone. That's all. Okay, you want the dates? I think dates is fairly easier, but still. Yes, Suresh, I have seen your question. Just a moment. Aryaman Patnaik, he has asked for dates also. So I'm pasting the dates here. And yes, Suresh, for how long am I supposed to share screen? Yeah, maybe there will be another presentation now, maybe after 5 minutes. Then maybe around 7:45, 8, you may have to, not now, in fact. So now this is almost time. Okay. So from 8 to 8:39. So till we complete this project, yes, you may have to share the screen. Okay. So hope it is fine with you, Suresh. Okay. Fine, no problem. Let's see how it goes, and then definitely yes. So I'll ask for another volunteer also. So just let me know when you want to step out. Okay. Okay, so hope almost everyone, you have downloaded your Google folder, that is a CSV folders. Fine. And yeah, so let's proceed the next part. Maybe I'll stop now. Suresh, you can share your screen. Yeah, it is visible. It's very much visible. So this is a typical sales forecast model. So please open Google Colab, everyone. Colab, yeah, good. So just follow like what Mr. Suresh Sharma is doing over here. Okay. So if you have any questions or if you are getting stuck, please ask me. Okay. So now like you open a new notebook, you name it. Is Jupyter okay? Yeah, I am fine. Okay. So if you are using Jupyter, it's still fine. Okay. But yes, few of the commands what we are going to use in Colab may not be required in Jupyter. Fine. So like ignore that. Okay. So name it. Okay. So what is the first step we are going to do? Because we got the data in. Okay. So like we have the data set now, but very simple data. Okay. Let me tell you like for real-time situations, 30 rows are like very meager. Okay. So like, it runs in 2 GB, simple number of rows, like, so even a simple CSV file, if you notice now in your particular desktop, it may be hardly 2 KB or 1.5 KB. Okay. But in actual, it runs to 2 GB, 3 GB, 10 GB data. Okay. Data sets are there. Okay. So just be aware of it. And now like, okay, so once that, the first part is, yes, we got the data ready, like very good. Now we are going to manipulate the data. So how are we going to manipulate the data? And for that purpose, data manipulation, you have to learn about something called pandas. Okay. So pandas is the data manipulation tool. Okay. Or data manipulation library. So this is based on Python. And yes, like, so I'll paste the code line to one by one. Okay, not everything at a time. Okay, so import pandas as PD. So we'll discuss every line of this. Okay, and yes, you need to type. Please do not copy paste. Okay, copy pasting, like, it will not help you because like it will never get you into that muscle memory stuff. Okay, so import pandas as PD. And here what we are doing is like we are importing this particular library of Python. Okay. So as PD, in the sense we are just making a copy of pandas in PD. Fine. So like you just run this cell, Suresh. So there itself, yeah, the play button, you can press that itself in Colab. Yeah, no problem, no problem. Now it is running. Yeah. So like if you see that the green tick mark, it says like, okay, your code is fine, no problem, fine. Or otherwise there will be, so this black color play button will turn red in fact. Okay. So this for those who haven't used Colab so far. And then like, since we are going to use Colab, we are going to upload files and all. Yes. like type this code because we need another library. So from Google, not import, from google.colab. Yeah. Import files. Fantastic. Okay. And again, like, yes. So this CSV, we need another library also, which is import IO, that is input output in Google. No, just import IO. So those who are not working with google.colab, you don't require the second line. No, you need not put no yes and all. So just we can refer to it directly. See, even in the case of import pandas as PD, you can refer to pandas as pandas dot. So you can do that, no problem. But again, like, so that will see that is not necessary, and it just make a instance of it. Okay, that is more easier. Fine, and hence we do that, import pandas as PD. Okay, and then yeah. So now we got to upload the file that you have prepared already. Maybe in the next cell you can do that. So that is the cell discipline. That is something what Jupyter Notebooks teaches us. Okay, so press plus code there at the top left. Yeah. So next cell will come. Very good. So that is the Safa Tabasum. IO is nothing but a package to read input output data, to read the input data particularly. Okay. Yeah. Now you can type uploaded file, uploaded underscore file. Does it have a full form? In the sense, IO is input output. So that's what you want to know. Okay. So uploaded file equal to files.upload. Upload, and you need to give those brackets. Just be like very much aware of using these brackets. Okay. See what is going to kill you in machine learning in Python. Okay, so pandas is the type of brackets that we use and indentations. Okay, so here what we have done is we are going to upload the file into like Google Colab. Okay, now run this, press the play button. Name files is not defined. Maybe like you need to run the earlier cell again, because that is where you have that import files. No. Yeah, just keep it. You run the cell. And now run the second cell. Yes. Okay, fair enough. Now choose files. So your CSV, whatever you have prepared now. Good. Book. Yeah. Very good. So you have the file already uploaded. Okay. Okay. So once it is uploaded, we need to read it. Okay. So what we have done is so far, we have uploaded it. Now we got to read this. So to read this, we are going to use, yeah, very good. You got the discipline now. Very good. Like, so this is the code, df equal to pd.read csv io.bytes io and uploaded file. So just be very careful in using those brackets and all. I'll explain the meaning of each and everything over here. Okay. Read underscore csv. Just give priority to underscore also. No, you don't need this. Like you don't need double quotes. First, you need to have IO dot capital B bytes. Yeah, BYTES. Yes. Caps I, yeah, bytes IO. So it shows. So this is one of the advantages of using Colab again. Like, it gives you this recommendations. Bytes IO, open a bracket and type uploaded file. Here you got to be, can you please explain how to upload file? Yes, yeah, sure. Just a moment. Okay, so we'll finish this code and I'll explain you. So uploaded underscore file. Okay, in your case, yes, guys, like you need to notice this. In my case, whatever the code I have shared, I have used uploaded underscore file. But Mr. Suresh Sharma, he has used uploaded files. So like you have to use like whatever the variable name you have given over there. So just be very careful. And whenever you change the variable, you need to rerun the cell. Let us be clear about that also. Yeah, now choose file again. Book sales, yes. Fair enough. So uploaded files. Now again, run this. The byte-like object is required, not dict. Okay, uploaded files. Like you need to give, you actually missed one part, book sales.csv. Yeah, Shin Kumar, just wait for a while. You need to type one missing part of the code, which is already in my chat. So you can have a look at it. Yash, now you know like how to upload the file. You got it? Yes, Sharma? Okay. Suresh, just be like, just see if you know if the chat contains double quotes or single quotes. Okay, Ashwin Kumar, like the error what you are getting is I'm getting the error message cannot read property underscore upload files of undefined. Maybe like you missed definition that is defining it somewhere. Okay, just wait for a only one code so that you can see like what you have created. Okay, so far, and then let's say that is one part of the story, and then we can answer all the questions, all the queries, whatever you have, guys. Right? Yeah. Okay. Okay, Raji, no problem. Now, like the next part, what you need to do is you need to see, okay, fine. So what you have done now so far is like you have uploaded the file, you have read the file in a particular variable, which is a df. Okay. So df, what is this df? Let us understand this. Df is any variable. Okay. pd.read.csv. This is we are using pandas to read this CSV file. You need to latently mention it. Obviously, you need to mention that it is a CSV file. I'm reading the CSV file. Okay. So you have read it. Now that you have read it, you need to make sure like it is read correctly. Okay. So whatever you have in your CSV file, whether you contain the same over here. Let's see. So type this df.head. Yeah, don't miss the brackets. Fair enough. Now run this. So you got it. But you got only 5 data, right? 5 rows of data. So what is happening here? Actually, head gives you only top 5 data. Okay. Let's say I want to see the bottom 5 data of the data set. What should I use then? So what is opposite to head? And you got a head? Yeah, very good. df.tail. So Suresh, you know pandas already? Very good. So df.tail. Okay. So once you have df.tail, like you have the top 5 and also the bottom 5, no problem. Now you can even check df.info. Yeah. Very good. So scroll down. So here df.info, why we are using, we want to know like what are the data types. See, actually data is no more the data what we have been perceiving so far. Okay, so in Excel, what we used to say, okay, fine. So this is data type something, take print out. So that's the kind of thing what we were doing, and maybe a bit of filtering here and there, maybe a VLOOKUP or HLOOKUP or some formulas here and there. But in this case, you need to be really, really careful about the data types. Fine. So here, if you notice, info gives all the information or top level information, particularly about the data set what you have in hand. Okay. So what we have, there are 3 columns. You have date, paperback, and hardcover, and non-null count, which means all these columns have like all data filled. It means like it doesn't have any missing data. Let me tell you guys, missing data is the most painful part. Again, like in your data sets. Fine. And yes, data type object. Why it is object? Because the date is an object, string is an object. So if you know programming, obviously you must be knowing this. Fine. But those who don't know programming, object is a data type which is there in Python or Java. Like say you have a different data types. You must have come across integer. You must have come across float. You must have come across character. Fine. But similarly, you have something called object. So string is an object. Whatever text you type, it's an object, and date is an object again. So it's an object, and paperback, it is an integer, and again hardcover, it is integer. If I have like 182.3, 182.5, so then in that case, the data type will be in 32. Yeah, Tapasum. Any questions? Just a moment. I think Tabasum has raised the hand. Okay, no problem. Yeah. So this is about df.info. And other part, yes, like next is df.describe. Yeah, good. So here, like df.describe, what it gives all the statistical measure of your data set. Okay. So here in these 2 columns, like paperback and hardcover, so you have all the count, mean value, and hardcover mean value, standard deviation, like minimum, maximum. So you can find the range also here. Okay, so why should I know this? Okay, why at all I should be really aware of this? So once you get into advanced or advanced level of machine learning, so you'll find that statistics and probability and data distribution, it is very, very important. Fine. So data understanding of data distribution is very, very important to model or to create a better model. Fine. So that's the idea. So you get in with the click of the button. Okay. However, like yes, this is already there in Microsoft Excel also. So if you just select all the columns, let's say, so like your numerical columns, you will find in the bottom right corner, you will find sum equal to or count equal to. But all these are scattered and it's in bits and pieces here. But in pandas, like it gives more or what do you say, rather than aesthetics, it gives more priority to manipulation. So that's the idea. Okay. So far clear, guys? Any questions? And yes, there is one more part which you need to know, which is df.shape. Okay. So you need to know df.shape. Yeah, shape should be without brackets. Okay, just a moment. I think Yash Sharma has an issue. Upload widget is only available when the cell has been executed in the, yeah, correct. So you need to rerun all the cells, fine. Suresh Sharma, could you please scroll up? And if you notice here, uploaded files equal to files.upload, fine. So here, like once you run this particular cell, fine, what will happen is it will keep on running and then you need to upload it, then only it will stop running. Right? There needs to be changes made in Chrome settings too before using this collab. No, you don't require any Chrome settings, any change in Chrome settings. Maybe like Yash, could you please share your screen? I can guide you then. Suresh, for a minute, yeah, thank you. Yash, could you please share your screen? Yeah, maximize it, maximize it. Okay. Scroll up a bit. Scroll up, scroll up, scroll up, scroll. Files.upload, everything seems fine. Rerun it, go to tools, tools. Yeah. You don't have anything actually. Okay, you run the second cell. Garima Sharma. Okay. See, for Jupyter Notebook also, you need to go with pandas. Fine. So you need to upload pandas, that is use pandas. Fine. And like wherever you are using this Jupyter Notebook, like whichever folder Jupyter Notebook is there. So there you need to place like this particular CSV file. Oh, okay. You guys are trying in incognito. Okay. Maybe I don't have that experience of trying in incognito. Maybe try in normal Chrome. So try it in normal Chrome browser. Good, Ashwin. So seems Ashwin also faced similar issue and now got it right, like by running it in normal Chrome. No, press code, yeah. Fair enough. So one learning for me, it will not work in incognito that I have learned today. Good. Fair enough. So now you can run your code as far as Mr. No, Suresh Sharma has done. Fine.
Raji, we are done. Yuvaraj sir, you can take it forward.
Sure. Just a moment. Hi, Aryaman, we'll start the project now. Okay. Okay, fine. So where were we? Actually, we got the files in, and again, we were able to see the different information, right? So particularly the statistical part, and obviously the data types and the information part also, right? Now that being done, let's get into the other part. So let's do some manipulations and then get into the model and quickly predict it. Yeah. So if Mr. Suresh Sharma is still there, he can share the screen. Yeah. Thank you, Suresh. Okay. So df.shape, we left it here, right? So what is shape? So shape gives the information about how many columns and how many rows we have. This is a very preliminary introduction to shape. Okay. So because we have 30 rows and 3 columns, looks good, fair enough, no problem. Okay, however, this shape part is very, very important when you are going to work with the numerical data. Okay, that is a conversion of this textual data to numerical data. And particularly for numerical data, you need to use the NumPy library. There you will come across this particular shape concepts in depth. Okay, so here, fortunately, we don't have much of the text data to convert it to numerical data, and hence we are going to go ahead with that raw data itself, because the raw data what you have in front of you is that in itself is integers, and hence it doesn't require any conversion, any type conversion. So the next part, yeah. So the next part is yes, choosing which column to use and which column not to use. Suresh, could you please scroll up? Yeah, here if you see, I have date, paperback and hardcover. Let's say I want to model only for hardcover. Okay, so I want to know how many hardcovers will be sold, and let's say I have 30 days of data here. On 31st day, know how many such hardcover books will be sold, and or on 32nd day how many will be sold. Okay, so those things we need to understand only for hardcover. I don't, then in such a case I don't require paperback as such, right? And hence I'm creating another frame. So this is of course, there was a question in the beginning of the session that yes, they wanted to know, what exactly is data manipulation. So what we are going to do now is typical data manipulation. Fine. So here, yeah, this is the code. Fine. So I'm creating a new data frame again using pt.readCSV. Fine. And same IO, bytes IO and everything. Okay. And then I'm going to drop paperback. Yes, yes. So maybe you need to work on uploaded files. Okay, so what we are doing over here is we are actually dropping one of the column. When you say drop, those who are not in tech, you need to understand that dropping means actually we are deleting that column. So that's what we mean by drop in tech. Okay, so we are actually what we are doing. So we are dropping or we are deleting that particular column paperback. Now you just see how exactly this df_new looks like. Maybe you can like, so df underscore new dot head, you can type. So that will give you the underscore new. Yeah. Dot head. Yeah, good. So if you see here, like you don't have your, paperback, you only have hardcover stuff. Okay. So fair enough. So like hope many of you were able to get this so far. Okay. So those who haven't got this, like, take time and understand once you get this like video. Yes, you can understand and take time. So that will help you. So it's a pretty easy, not really not tough to do. And here, like what we are going to do, another thing is, yes, we have date and we have hardcover. Like date is an object. So that's what we have seen already. So date has to be converted into something else. Okay, so I cannot just like that work with date. So hardcover, I'm perfectly fine. It is a numerical data. So my model will take it happily. Okay, but date, obviously, it will not take so happily because it will not understand what exactly is this hyphen, this 01, this 04, all these things. It will get confused. And hence we are going to have a kind of a dummy data. Okay, so for that purpose, this is the like only numerical manipulation what we are going to do. Okay, so we are going to import another library, import numpy as np. So as you guys know, like all these are about libraries. So at the crux, what you need to understand is like you need to be really strong in these libraries. Of course, there are multiple libraries in this Python ecosystem. However, like if you're really strong in pandas and if you're really strong in like numpy, so that itself will be actually like that itself will be very, very good. Okay. So because you can understand many things from here. So import numpy as np, very good. Now what we are trying to do is like we are creating another column, let's say. So df underscore new, yes, good. So df underscore new. I want to create another column, time. So just bracket, you can open a bracket, square bracket. No, only the square bracket, not the code. Yeah. And with single quotes, time equal to np dot. I think I have. You can check my chat. Yeah. So np dot a range, like so this is one of the functions in numpy which checks how many columns are there and it creates how many rows are there and it creates equal number of rows in the new column also. Fine. Now again run this df underscore new dot head. So here you got date, hardcover, and time. Okay. So why we are still retaining date? So like we are not going to use this, but again, like why we are retaining date? This is just for our reference purpose. Like if I want to go back and if I want to see, so even if there is no paperback, I don't have a problem. But again, like if I don't have a date, I may miss something. Like let's say I want to see like manually, I want to do some calculations, some manipulations outside this like a laptop, maybe in a paper. Then yes, this date information may be required, and hence I'm keeping it as it is. However, the date information actually like that is being converted into some time. You can say like this time is nothing but 0th day, first day, second day, third day, and fourth day, right? And here you will notice like the time starts from 0 because there at 17 in the there at 17 like what you have is df underscore new dot index. Okay. So this range, like in NumPy or in Python even, so like whenever we talk about array or whenever we talk about list and all, so we follow 0 indexing. So the first question is always 0, second question is 1. So that is how it runs. And hence, like, since we have used np.arange, so we are getting, right, a 0, 1, 2, 3, 4, in fact. Okay. So hope that part is clear to you. And then, like, yes. So I want to see, like, I want to plot this. Okay, fine. So I have seen the data. So like we were able to get this done. Fine. I want to plot this, and I really want to, like, check how this looks like. Fine. So whether there is a trend line, and like whether I could get some information out of this. Yes, this plotting is at the beginning it will be a bit complicated. Okay. However, like as you go, like you will find that the plotting is the most easiest one when compared to pandas or numpy. So I suggest, like, you just copy this code and paste it. So rather than trying to type it. Okay, so I'll explain as much as possible, as much as you could understand as a beginner. Okay, so like then we'll go ahead on this. So here, if you notice, yeah, so copy the chat. Yeah. So here, if you notice, like for charting or plotting, we have used import matplotlib, and also we have used import Seaborn. So these are two different libraries, plotting libraries. So on a whole, like we have, what you have seen today is primary, even like, some introduction to the different libraries, what is required to run a proper, like a Python project or a proper machine learning project. So if you are so these four libraries like will come really handy. And of course, there is another library we are going to work. So these are the that is algorithmic library. These are the 5 libraries, you can say. Okay, these libraries are more than enough to run any algorithm. Okay, unless and until like there are some special problems or like a special requirement. Fine. Otherwise, if you have thorough in these 5 libraries, you are doing a good job. Yeah, you can run this. Okay, so this is how, like, this is the plot of your data. So what we have covered, and this line actually, those points and the lines connecting it, like the zigzag lines, are actual data, and machine learning will learn only that line which runs through the trend line. Okay, the blue color line, what you have. So that is what the machine learning will learn. Okay, it will not try to plot each and every data. It will not try to follow all the data. It gets a kind of what do you call a pattern out of this. Fine. So what and all we have to do over here once you get this data and all. So what and all we got to do? Maybe like we need to remove some outliers, some extreme cases we need to remove actually to make it a bit more accurate. Fine. So this is on plotting. So once you have completed your plotting part, so like this plotting is actually not necessary to go for model, but yes, like once you plot this, you'll understand like how this data looks like and what could be done. Fine. Now we are getting into the modeling part. So copy these 2 libraries. Yes, we are going to use linear regression. Just a moment, Ariman. So run these 2 libraries. Okay, and in the actually like sklearn or scikit-learn. Okay, so scikit-learn, SCIKIT, scikit-learn. No, let that be sklearn, but scikit-learn is the library website. Okay, scikit-learn.org. So there, where like you can learn about various such algorithms. Fine. So here we have taken what is a model and metrics. The metrics actually gives you the understanding of the accuracy levels. Okay, so whether the prediction is as per the accuracy or not. Fine. So here, like, okay, so now you have plotted and you are ready for modeling. Now you need to actually like what to model against what. Fine. So that you need to be clear. So for that purpose, first we need like labels and features. Okay, sorry, targets and features. So X values are the targets, features, sorry. Okay, so another line of code, please. Yeah. So what you have done is like, okay, so you have taken, so the time column alone, okay, the index and the time column, features. So these are called features. The columns are normally called features, and we take only time because we don't need date. Okay. See, the basic idea over here is in which time, like what is the sales, right? The I have hardcover sales, fine, is the data, and I'm going to forecast the data. Forecast the data based on what? So based on the time, right? Like the first day, this was the sale, second day, it was the sale. So you have all this data, maybe like on 30th day or 25th day, what is the sale? So that is something what we need to understand. Okay. And again, like, yes, the target. So what is the target? You need to be clear to the model. Okay. So clearly you need to communicate this to the model. So yeah, it's in the chat. So you have to like take up the Y value. So if you see, like I have a data frame. Yeah, Aryaman, just few minutes. Okay, so we are almost going to complete this, and hence, and after that, definitely I will come to you. Okay, just excuse me for a while. Okay. So you have this X, you have this Y, and now like, okay, so the data is ready, fine. So features, you know, like what is the feature, time is the feature, and target, hardcover is the target. So just like if you look at the top, like you have time in the x-axis and hardcover in the y-axis, because like we are going to we need to actually plot that only, right? Okay, or we need to understand how this is, how to model this. Now we are going to train the model. So the model is a linear regression model, what we are going to use. So yeah, again, back to my chat. So if you notice, like I'm defining the model to be linear regression, and I'm fitting this X and Y value to that linear regression model. Paperback, so okay, Garima Sharma, sir, can we use paperback instead of hardcover? Yes, absolutely, you can do that. But this project I have used hardcover. Okay, actually you can use both also, but that requires a bit more sophisticated algorithm, which will take a lot of time to really work on that. And we need to understand the multivariate calculus part. Okay, multivariate regressions, not calculus, multivariate regression. And hence, I'm not going ahead with paper cover and hardcover together. Fine. So you can try that with paper cover also later. Fine. So like even in scikit-learn, you can use multivariable regression. So that will help you to get the idea. So model.fit. So here in this case, you have like fit the model. And now, yes, I need to predict. So what am I going to predict? So now your model is ready. Fine. So this is perfect. And what you're going to do is like you're going to predict actually. Okay. So what exactly you are going to predict? You're going to predict hardcover sales, right? Hardcover sales based on time. So again, yeah. So please refer my chat. So understand what are the variables we bring in and to get this predictions. Okay, so far what you have done is like from sklearn, so you have defined X value, you have defined Y value, in the sense you have defined the features and targets. Features are nothing but the columns, and target is the column. Target is also a column in fact. Okay, but again, like that is the value I want to predict. So it is not other way around. Like a hardcover, if I put hardcover in years, and time in Y. So like that is not what I really want. So I don't want to know like when I will make 200 number of 200 copy sale. Like no, I want to know the time. So that I will not do that. That I will not do actually, because that is not how things work in in reality. Okay. So here, like then what we did, so we actually used this model, linear regression model. We called it, and again we took an instance of it, and we had dot fit. It tells you that you have to fit these two data, X and Y data. Okay. So you actually have fitted this data to the model. Now model will take care of everything. Now model, and again in the next thing, if you notice YPRED, yes, YPRED you got model dot prediction. Okay. So in model dot predict, based on the X value, I want to predict the Y value. Okay. So I'm using the same data to know, let's say I have like, I have some realistic data, real-time data, and like it has some X value and some Y value. For the same X value, after like this model being run, what is the Y value I'm going to get? Fine. So this we did. Now let's say I want to print the accuracy. Okay, so print metrics dot. So R square, like R square score is something. R square number is something. No, that is like that is one of the metrics to understand the goodness of fit. If the curve has actually like so it was fitting as per our requirement. So 0.52 it says like 52% fit is there, which means like so your predictions can be 52% true most of the times. Okay, so with this like simple analysis without any any other manipulations, so you are able to get 52% accuracy. Okay, so like actually more the R square value, obviously like you will get so closer to 100% accuracy. So that part is always there. Fine. And like once you get this, yes, how does this work? When we say linear regression, so the linear regression is given by the formula y equal to ax plus b, right? So let's say you want to understand the equation of that line. So whatever the line, the blue line, it is there in the plot. So you want to understand the equation of it. So you know y value, you know x value, obviously you have two columns, but what are those a's and b's? And that is calculated by your algorithm. That also you can actually a is you can call that as like whatever comes with the variable, it is a coefficient, and whatever doesn't come with the variable, it is an intercept, right? So we are going to print both. So we are going to see what is the a value and what is the b value. Yeah. Good. So typically, what you have here is an equation of the form y equal to 3.27x plus 151.74. So this is the actual equation on which your total model is running, or rather, the total model is running, in fact. And it comes out, and this equation keeps changing depending upon the amount of data what you could insert. Let's say today you go back and so work with, of course, you have created 30 data. So like make another 300 columns, 300 rows or 3000 rows and try with this. Okay, so obviously like, you will find it more interesting, and this coefficient and intercept values will keep changing. R square value will change, the prediction will change. Fine. Which one? Which model you want to see? Mr. Rao? Okay, fine. So, any questions? Line number 25. PD.series. Okay, so PD.series is just like we have used. Okay, what is series? Series is nothing but one single column. Fine. So one single column. And line number 25, yes, like we are talking about PD.series, model, predict X, index, X dot index. Maybe like okay, Suresh, could you please go to 25? 25. And there like you, from here, you create another code chunk plus code. No. Another code chunk, yeah. So you just print ypret, print, yeah, y_print. So let's say like we want to print, maybe this will give you more information. Yeah. So index, x dot index, fine. So x is time, right? So like in 22, if you notice, x is like we have taken time and the time is being displayed as index. And here the model has predicted the y value. The model has predicted the y value. So if you scroll up, could you please go up? Yeah, a bit more to the data frame. Yeah. So just to see like what was it for 0. Bit more, yeah. So here, if you notice for 0, the hardcover was like time 0, the hardcover value was 139. These prediction will differ for all. Yes, it will definitely, because if you notice, could you please scroll down? Yeah, very good. Yeah. So here, if you notice the prediction, a bit more up. Sorry. The prediction a bit more up just to see the graph. Yeah. So if you notice, the prediction is nothing but the line, the blue line, which is running over here. This is for linear regression. Yes. Okay. So the blue line is the prediction. So like if the line is extended, like whatever the value, if I go for 31, obviously if I extend the line, whatever the value I get, that is the prediction I get. Okay. So the predictions will not be exact match most of the times. And if you see only few data points, maybe 5 and 6, like maybe 8, yeah. So those data points, it falls exactly on the line, and this is not bad. Okay, so like 52% accuracy is not actually recommended. See, there are two things whenever you go for modeling. One is like overfitting and underfitting. When we say overfitting, like 100% accuracy, 100% accuracy is also not required. Okay, 100% accuracy is also actually such models it will fail in practice for all practical reasons, because all of a sudden when the data changes, there is no room for like imperfection. So when there is no room for imperfection, it will definitely like it will definitely fail. So that is on overfitting part. And underfitting part, yes, like 0.52, it's just 52% accuracy. So like that's also not recommended. Maybe anywhere between 80 to 85, if you have accuracy, then you are doing a good job. Fine. Maybe like how I can improve this accuracy, let's say. So that's what I said. Like after this session, like you can always work with the number of data. You increase the number of data, the accuracy will also increase. Fine. So like as much as training data, see, that's the reason like why we use big data stuff and all. Simple point is like in big data and all, like obviously, so you are going to like work with the MBs and the GBs of data. Okay. Clear? So far clear? Yeah, Yash, I consider that. So prediction will differ. So what are some of the prerequisites with respect to data set for linear regression model? Should all the attributes be normal? No, because you cannot push the like. Okay, fine. Maybe I yeah. So I think you are talking about the data input part, fine, not the raw data. Okay. So if it is raw data, yes, you cannot force that. Okay. So numerical or text, whatever comes, we have to take. Fine. However, if you are going to like bring it to the model, bring into the model, fine. So definitely like you need to actually use the numerical part. Yes. The input data for creating the model. Yes, it should be numerical. So like here it is very easy, like we were able to create simple numerical data, but you talk about NLP, you talk about the computer vision. So such projects, it will be matrix of matrices and tensors. So too much of mathematics. And yes, like a very quick pen paper demonstration to summarize what we have done so far. Yes, Suresh, I'll share my screen now. So hope you guys enjoy this part of project. Actually, yeah. So machine learning is no, it's not so don't have the fantasy part always in mind. Yes, there is a lot of hardware behind it. Okay, so this 0.52, if I say 52% accuracy, to bring it to 82%, that's going to take the life out of you. It will make your life hell. Okay, so that's the kind of work which is required, because you will you will increase the data, you will decrease the data, you will see the distribution, all this you will do, and at the end of the day you will get only 65%. So can I know how to merge two data types in pandas? Can you show how values for future dates can be predicted? Yes, future dates, I leave it to you guys in the sense you can prepare a CSV file. Okay, so and then you can run to get a series this Y prediction series. Fine, and then see, obviously it will work. Okay, so for a quick summary, so what we did, we prepared the data in CSV. So we manipulated in the sense we dropped unnecessary column. Okay, and also what we did, we introduced time column, another time column, so which was required because the date object your model will not really take, and hence we took time column. Fine, and these two things we did, and again yes, so we plotted the data. Just yes, Suresh. So how we, let's say, get value for 30-second row? Yes. So if you want a 30-second row, obviously prepare a CSV file. So just mention 31, 32. Okay. So in place of time, and then load it again in Xspread. Again, in place of X, you need to change that. Okay. So in the predictions, in fact. Okay. So then you should be able to get that. And yeah, so the plotting part. And then what we did, once this is done, this data, the numerical part is we actually see what we did. So whatever is not required, we dropped it. And whatever cannot be converted into numerical in a meaningful way, so we brought in some dummy columns like time. Okay, so we had some analogous column, and these columns really helped us. This is actually if I have the first day of the month, so I can say 0, second day of the month, I can say 1, third day 2, and all this stuff. Okay, and again we send this as an input, this data part into input, and we got the output to understand the prediction accuracy. And of course, we understood the prediction accuracy part also. And yes, what happened here is, so I have these data. Okay, so this is how the data is being spread. And let's say this is the linear regression line. And the equation of this line is y equal to 3.7x plus 151, if I'm right. So roughly yes. Okay. And yes, Suresh, if you want to calculate for 31st day, so you need to input 31 over here. Okay, so that you will get this answer. Fine. So if it is going to be, because if you want to do this manually, once you know this moving stuff. Okay, and however I have 52% accuracy only, so which means my starting value itself is 151, because when x takes 0, so I take 151. But if you notice in the actual data you have 139 sort of, right? So we need to see we need to maybe remove few data or add more data to understand how this intercept value can be brought closer to 139. So once you could bring this closer to 139, I think you will be getting more accuracy. So that kind of abstract thinking you need to have when you are working with linear regression models. Yep. Yes, you are able to get this. Okay, Suresh. Suresh Sharma, thank you. Thanks for your help. Fair enough. Yeah, it's a linear regression. Yeah, good. And yes, there was another participant was having errors. Sorry, I missed your name. Ariman Patnaik. Are you still there? Ariman? Yeah. So could you please share your screen so that like I can check. So what is the error and like, so we can get things off. Yeah. The problem got solved. Okay. So I'm curious to know. So like how you got that solved. Okay, fine. So as long as it is solved, I'm happy. But if you could share like how it is solved, yes, it's fine. R square value. So who got? Yeah, it's good. Oh, okay, okay. It was a name error. That's fine. R square value is 0.53. Yes. So you need to try to increase that. In fact. Okay. So yes, this R square part, and again like so this and all. Yes, the next level learnings what you need to have. So which is very specific to your algorithms. Fine. So when we talk about R square, it's nothing but like your variance of the model divided by the variance of the total the actual data. Fine. So that is the basic idea behind the R square value. Okay. So all these are mathematics part which you really need to work on. Okay. So once you do that, yes, you're good to go with ML. See, actually, ML is like fairly easy and fairly easy in the sense like okay, it's not some rocket science where which you can't understand. Yes, you can understand, but a bit of mathematics is definitely required and a good practice. Fine. So that's something what you need to work. Okay. So like if you put some 3 to 6 months of like focused hard work, yes, I think you should be able to crack this. No problem with that. Good guys. Any more questions? Yeah, Yash. Yes, Yash.
Hello.
Yeah, yes, Sharma.
Sir, my
I'm here.
doubt is that R2 score value is 53.
Right.
So how much variance is like acceptable in a particular data?
See, in a particular data, like see, if R square value is around 0.8 or 0.85, you are doing a good job. Okay, or rather, you in the sense the model is doing a good job. Okay, so like we need to work towards that. Fine. So this is like a 48% variance is there. Okay, so 0.52 is not variance. Okay, the variance ratio between these two. Okay, so actual data variance is almost 48%. So if we could bring that closer to 20% or like 15%, we are taking good. No, that's what is the requirement. So can we get the notebook link for download? Okay, so you try this, Aditya, like you go through the video. I think Suresh Sharma, he covered almost everything. So no code is missed. Try this with the video. And if you are not able to get that, so like you can shoot a mail to like a GUVI and they should be able to help you. Yeah, Yash.
Hello.
Yeah, yes.
Sir, like you told us that R square value should be around 0.20, right?
No, R square value should be around 0.8 to 0.85.
0.8 to 0.85.
Yes, it should be closer to 1.
It should be closer to 1.
Yes, R square is not the variance, it is 1 minus the variance.
Okay.
So like when I said 0.2 or 0.15, if you talk about the variance is 1 minus R square value. So that is something like what you can take as a thumb rule.
And how can we do that for this particular data, sir? Like we already had
one thing is like we work only with some 30 rows. Okay, so 30 rows is not going to really help you. Okay, so you need 3,000 rows, you need 30,000 rows. So once you keep increasing the data, you will see that the more the data, like more normalized it will be, and the variations will also be lesser.
All right, sir. One more thing, like if we manipulate the data, then the like sir, data won't be real data. Like we collected some data
Right,
from some source,
right.
usually customers or consumers.
So
And
if you manipulate, yeah, I agree. Like, you know, where you're coming, I could see that. See, if you manipulate, yes, we may not really fall into that, like, you know, proper variance stuff. So there could be a lot of bias also. Okay, in such a case, I would always recommend you go ahead with public data sets which are available in, let's say, in Kaggle. I don't know how many of you have really worked with Kaggle. Okay, Kaggle, Kaggle. So there are a lot of data sets, so which you can take and you can work with. Okay.
sir, but data originality will be like.
Okay, fine. Maybe in Kaggle, I missed this point. The Kaggle actually gives only the original data. Fine. Actually, Kaggle is a data science platform, like where you can compete with others also. Fine. So once you get some confidence in data science, fine, in different competition projects, because what big companies do is like their research projects and all, like wherever they have the data and it's in research, let's say, so they don't want to hire people. So what they do, they create a competition in Kaggle and they give you prize money also. So if your accuracy levels are as per their expectations, fine. So like you always come across original data over there.
No, sir. The point is, sir, you told us that if we need to bring the variance to around 0.20, or this R square value should be around 0.80 to 0.85.
Exactly. Yeah.
So, sir, this is like the data we have. We are actually making changes into data. All right, sir.
Yep.
The data doesn't be the real data which we actually sourced in the first place. If we are, that's what I'm asking. So how can we expect a real answer?
Okay, fine. Like, see here in this particular case, in today's case, so what I have done is I have taken only 30 rows of data, right? And 30 rows of data, even if it is original, it will not give you better performance because the machine will not actually see 30. If let's say, I'm going to delete 3 data, let's say, out of this 30. So what is the percentage of data that is getting deleted? Almost 10%, right? And hence every data point becomes so important that the machine learning, that is your model, will get confused, or it will take the worst scenario possible, fine? And hence it fits your data to the worst scenario possible. Okay. And however, if I have, let's say, 300 and I'm going to delete 3 data, so it's not going to make so much of a difference. So like the more you increase the data, the more you increase, you'll definitely get a better accuracy. This is like this. I'll give you a simple example. Like you are tossing a coin, let's say. So what is the what is the probability of getting a head?
50%.
50%, right? But let's say like you toss twice, and again let's say you are getting the hit both the times. What will happen?
Okay.
So is the probability going to change?
Yes. No.
Okay. Actually, no. It should not change, right?
Yes.
So now I cannot go and say that okay, the probability of getting hit is always 1. Okay. So what happens over here is you need to increase the number of tries, the probability or the linear regression. Wherever we talk about, you need to keep increasing the number of tries. So let's say if you are going to toss for 1,000 times or 10,000 times, I bet like the number will be closer to 50. Okay, so if you are going to toss for 1 lakh times, obviously it is going to be almost 50. So the more the data you have, like it will actually meet your theoretical expectations. Okay. So that is the reason why like this 30 numbers, it's very simple. And if you are going to work with 30,000, the result will be entirely different. And here, when we manipulated the data, we didn't actually touch the data values. We use this column, you use that column, that's all. We didn't touch the values actually. Okay, touching the value, yes, it will lose the originality. Okay, so like you should not touch the data values, but yes, you can manipulation in the sense I'm trying to get the insight. Okay, so let's say like I have 10 people in a crowd, and again 3 of them they are earning around 1 lakh or rather more than 1 lakh, and there are another 3 people who are earning more than, let's say, 5 lakhs, another 4 people who are earning 10 lakhs. So this is the data value I have. Okay, I cannot change your value. Let's say if you are one among them, let's say if you are earning around, let's say 5 lakhs category. Okay, so like more than 5 lakhs. And then I cannot change your 5 lakhs. But what I can do is maybe like, okay, so your name is Yash Sharma. I want to know like how many people are there whose names start with the letter Y. What I can do in each and every batch, let's say there is one person. Okay, with of course I am no Yuvaraj Kriminal, I am there, and you are Yash Sharma. Let's say there is someone else, find some another Yash in another group. So there are 3 people over there. This is insight. This is manipulation. Okay, here we are not touching the value. We are just actually reorienting it, transforming it here and there to understand what exactly or rather what kind of insight we could get. That's all. Right?
Sir,
Yeah.
Just one more thing. It may sound so sorry for your.
No problem. Yeah, please.
Sir,
please.
the point is when I was reading a statistics book, the first chapter was like it says that sample is the true representative of data. All right, and the whole idea of statistics is to study the sample.
Right.
And when we are studying a sample, so they itself tells us if we have more values, it won't give you better outcomes. So that's why we study sample. The results we get out of sample are more accurate.
Very good observation. Very good observation. Okay, see, there is a threshold to everything, right? Okay, so even let's go back to that tossing a coin stuff. Okay, which was actually a right example here. Let's say 1 lakh times I'm tossing. Fine. So when I tossed 2 times, so I assume that the probability of getting hit is 100%. But 1 lakh times when I toss, let's say I get 48% hit and 52% tail. Okay, so which is close to 50%, which agrees with your theoretical calculations also. And if I'm going to make, let's say 50, from 1 lakh, I'm going to increase the number of trials to 1 crore, let's say. Fine. If I'm going to increase the number of trials to 1 crore, this particular distribution may become at the most 50-50.
Yes.
You're getting the idea. So 0 to 1 lakh, I got a tremendous change in the output or the insight. However, from 1 lakh to 1 crore, another 99 lakh, I didn't get much of improvement in the data. So that is true. So as you said, yes, in population and a sample also, this is true, and it is not it is not contrary. What the machine learning is not contrary to that. It still respects a sample and population. However, we need to know what is the size of it. Okay, there is always a threshold size beyond which it is not going to help you. Okay, so
yes, sir, there is also a formula for the sample size from a population.
Yes, so there is a formula, and there are different formulas in fact.
Because if we go for 1 crore, these samples, samples, this population, 1 crore, it can go 70 also, 70%. It may not be around 50 less.
Exactly. So it could be it again depends on what data we are looking at. That's all. Okay, so what is our objective? In the sense, if 1 lakh I'm getting 48% and 52%, I may go up to 2 lakhs. I will not go for 1 crore or even 70% of it. Okay, the simple reason is, okay, I want 50-50. So chalo, at 2 lakh, I'm getting 49%. Still fine. I'm coming out of this experiment. Fine. However, if I'm not getting even at 2 lakh, I'm not getting the required output or required insight. So obviously, then I need to keep increasing the sample to see that it has to meet. See, when we say population metrics should meet sample metrics, what we actually mean is the experiment should meet theory. That's all, theoretical calculation. So that's the idea.
But experiment should meet the reality actually.
Yeah, the reality. Okay, the reality. And the reality is again, this is a bit philosophical, but still, okay, so the theory is nothing but reality, if you notice. Because, okay, in the sense, I have a theory that, what is the percentage of, what is the probability of getting ahead? I say 50%, and 50% is reality in the long-term basis. Okay, it is theory and it is reality too, right? So you can argue that. And of course, yes, when we say reality, if I'm going to shrink that reality, the time frame of the reality to, let's say, 2 minutes or 5 minutes, yes, then like, yes, the entire definition changes. Okay, the statistics or probability, it is written for something which happens in long time. Statistics for long time actually. So it's not for short term, in fact. Okay, good points you have brought up. And I do see there is, yeah. So any more question? Yes. Okay, good. So Garima Sharma, I think there is a one question. Sir, you said with increase in data, the accuracy increase. Lesser the data size, lesser the accuracy. Yes, exactly. So the meager the data, what you have, so like the accuracy will really not really not be high. However, like even in increase the data, you will come to a position wherein like increasing further, it will not help you. So there is always a threshold, and that threshold can be arrived only through proper trial and error. Okay, so you don't have a specific formula. Okay, but normally we go with you need to have at least 1 lakh data points, and at least 1 lakh in the sense 80,000 data points we take 80% of it. Okay, so that is something we use as a thumb rule. But again, that is also not sacrosanct. So you really need to it may change with the from time to time. So that is one part of the story. What to do if data is missing? So delete the row as long as like the number of rows are less. And if the number of rows, like let's say, if the missing data is almost 10 to 15%, then you need to impute it. There is something called imputation, which happens in machine learning. This imputation should be based on like your mean and variance. It should not disturb the other data. Okay. So like it should like you need to impute such random data in such a way that the mean and standard deviation or variance, it is going to stay the same. That's a nice point. Yeah. Good. Okay, guys. I think any more questions? If you don't have any questions, just like we have come to the end of this session. Yes. So this is the project I really wanted to go ahead and hope like this project covered all facets of machine learning as such. Okay. Yeah, Garima. Just a moment. Raise the hand. Ariman, you can straight away save in GitHub with Colab from Colab. So there is an option where like you can save directly to Colab. Irma, I'm trying to unmute you, but ask to unmute. With the download. No, I think like you save directly to GitHub is there. You need not download also. Yeah, Garima, like your question, like you can ask in chat because I'm trying to unmute you. So what should we do to start statistics as beginner? Okay, so do as many projects as possible because this is a very tricky question again, right? Like if you want to get into statistics, you'll try to become a so it will pull you so far that you will try to become a statistician and you'll forget that you wanted to learn this for machine learning. Okay, so for that matter, anything for let's say if you want to learn about matrices, if you want to learn about calculus for machine learning, so you don't require you need not be PhD in mathematics. Okay, but only a few parts of it is required. Some basic statistics, yes, you should learn. But again, like I would always suggest, you should do that by starting projects. That's the first step. And the second step is like I'll always recommend if you want books, go back to your 10th, 11th, 12th standard CBSE books. Fine. So that is more than enough. Okay. So to understand these parts. And then yes, like as you go ahead, of course, this is for beginners. And again, like if you want to go ahead in your career with more knowledge and accumulate more knowledge and you want to improve, like then obviously. So as the path goes, you need to learn more, and which you will do further. Okay, for sure. Yeah, Yash.
Sir,
Yeah,
sir, like just we had a coin example, na? The head
Right.
or tail. Sir,
Right.
in that particular formula, we use the number of outcomes divided by the particular outcome, that like heads or tails divided by number of outcomes, that is total number of outcomes, that is 1 plus 2. 1 plus 1,
right,
2.
right. So sample space, yes.
But when in reality, when we toss a coin,
Ah,
it doesn't comes out 50 or 50 every time.
Right.
So isn't this idea of using the probability absolutely wrong when it comes to
No.
practicality?
That's what like I try to explain. Like philosophy and philosophy in the sense theory is equal to reality. Okay, that's what I try to
Yes.
explain in the sense this probability or statistic whenever we speak about. So this is actually like these theories are framed based on long-term basis or huge number of trials. It is not for one trial or it is not for two trials. Okay, it is for like crores and millions of trials. So that is the idea. So what it says is basically like you forget about like this coin or whatever. So whatever goes up, it has to normalize somewhere. Okay, it cannot like have that. Let's say like I toss the coin 3 times. It is I'm getting only head. It is 100%. It has to normalize somewhere. So if it has to be normalized, what is the alternative available? The alternative available is getting a tail. So which means as this goes down, that will increase and there will be an equilibrium set. And at that equilibrium, number of tails, what you will be getting is almost equivalent or approximately equivalent to number of heads, what you will be getting. So it's more, kind of philosophical stuff. Yeah. So that's the idea. So like probability is not wrong. But again, like probability for tossing a coin, assuming that this is the reality on which the probability is built. Yes. So that's where we make assumption-based mistakes. Okay. Clear? Good. Okay, guys, learned anything today? Anything new? Okay, so hope you guys enjoyed the session and all the best for your future and do practice a lot with many projects like so all the best, guys. Fine.
Thank you very much, sir. I
Yeah,
hope
thank you.
everyone have enjoyed this session. It was really a wonderful session that we had today. And Deepak, do you have something to say?
Yeah, Rajeshwari, let's wait for 5 more minutes. And I believe already a lot of students, 15 students have already registered. So we'll wait for we'll give them an opportunity. Maybe 5 more students can register and take it forward with this opportunity. Guys, I'll be sharing you a link again. Just finish off the process because we've already requested, because there have been a lot of requests happening. So already 15 students have already enrolled, but we are increasing the limit to 20. Maybe people who haven't register it immediately and share the details on WhatsApp. So people who have already registered, thanks for taking it forward. So you'll be getting a basically a call tomorrow morning 11 o'clock regarding the same on when is the pre-boot camp happening and stuff. So guys, few more opportunities, like let's open it for around 5 more minutes, 5 to 10 more minutes, Raji. So we'll give them an opportunity for 5 more students to register and share the details immediately. Okay guys, thank you. Let's wait for 5 more minutes, Raji.
Yeah,
We'll give them an
sure.
opportunity to take this.
Guys, utilize the wonderful opportunity.
And for people who are asking for the coding docs and the recordings, it will be sent to you tomorrow before 2 p.m. The recordings and the code docs. Yeah, thank you. Deepak sir, there's Aryaman. I want to know the benefits for a first year CSE guy for this program.
First year students, guys, I'm going to, tell you 4 specific points for you. one point would be every semester we'll help you out with an internship. I believe Anna University or Anna University has brought in a new rule that every semester you'll have to go for an internship, correct? So we will particularly help you out for each and every semester internship, and so we'll help you out for your, basically, let's say, for example, for your final year project. If you're finishing off your final year, once you step into the final year, you will have to prepare for your project, right? So that can be done at IIT Research Park itself. And another most important thing here is, you might be, let's say, for example, in your campus, if you're getting placed for around 5 lakhs or 6 lakhs or whatever package that you're getting placed for, okay? So we will give you an opportunity to give you companies only about 8 lakhs or 10 lakhs. The relationship that we are going to maintain with you guys is going to be for the next 4 years. It's not going to be 1 year, or 2 years. The relationship that we'll be maintaining with you is for the next 4 years that you're going to maintain. And the best part here is, obviously, you need to be strong on few core things. Let's say, for example, you got to be strong on DS and Algo. If you go for any top product based companies, right, you got to be really strong on data structures and algorithm and system design. And when it comes to data science, you got to be strong on few core things. So we will particularly train you on that stuffs to crack you into bigger companies, guys, actually. So we are going to, the relationship that we're going to maintain is completely for the entire 4 years, and you can also attend the pre-boot camp. So utilize this opportunity, just block your seat for the pre-boot camp, understand what are the benefits that you're going to get by joining the pre-boot camp, then take it forward, guys. Actually, I'll be sharing you the link again. And I believe that few of you guys are calling on the same number. But anyways, tomorrow morning, our team will call you basically to help you out for the same. And already 15 students have 15, now 16 students have already registered and given the details. You guys who have paid the program fees would be getting a getting a call by 11 o'clock tomorrow. Of you have asked for recording, correct? So we will be providing you with the recording, guys, actually. So don't worry about it. This recording of the session would be provided. Yeah, so basically, we will be providing you, there's questions coming up where, internship will be done at good companies. Yeah, we will only focus on good product-based companies. If you perform well, even we will, make you as an intern. We would, make you guys join with us as an intern, and it can be paid and unpaid internships as well. But the best part here is, once you get trained on with GUVI, right, we can help you in your paid, internships as well, guys, actually. Aryaman. Wonderful, nice, connecting with you. And to be frank, it's 9:20 and you guys are still in the webinar. That shows the commitment that you have. That shows the effort that you guys have been putting. You can, Adiman, you can just go ahead and, share the details and take it forward. And I'm getting few questions. I'm from, I believe just internship in remote. And if you are from UK, and we have a lot of candidates applying from UK, US, and Canada as well, we'll be providing you with remote opportunities. Don't worry about it. Yeah, so you'll be getting your today's certification as well, guys. So you'll be provided with a certification, maybe 7 days, 7 working days it will take.
Yes,
you'll be provided with that.
Yeah.
And any other questions that you have, guys? And last, and already 18 have registered, only 2 more seats available. You can take it forward, guys, actually. Final opportunity to grab this opportunity. Around 24,000 you guys are going to save. So just go ahead, take this opportunity to, utilize this offer and take it forward. This is going to be a lifelong relationship that we're going to have. The relationship doesn't end once you finish off the placements also. We would help you even after you getting placed. We'll help you out for the same, guys, actually. That's the kind of relationship that we're going to maintain and take it forward. Let me know the procedure to apply for internship. So you'll have to, first you'll have to attend the, program that we're going to conduct. We will train you and then we'll be start providing you with internship opportunities, Jayashree. This is a procedure. I'm sharing the procedure to block the seat. And once you, block your seat, you'll be attending the pre-boot camp. Once you finish off the pre-boot camp, you'll take it forward, guys. 5 more minutes, giving you opportunity to, grab this offer. And once done, just share me the details, guys. Yeah, so internship is basically for people who complete the program, because I'll tell you, Jayashree, the reason why we are confidently telling you that we can provide you with an internship is basically because you're going to be trained on the requirement from the companies. The companies give us the requirement, right? They will share the JDs with us. So we will train you as per the JD and we will provide you with an opportunity. So that becomes, and one more thing, guys. So as I told you, only first from, maybe you might be from first year, second year, third year, or fourth year. So once you finish off the program, so once you finish off your degree, then also we will take care of your placement. It doesn't end only with the internships. So after your fourth year, we will help you with the placements as well. We have had examples. We have had Miss Aishwarya. She's from SRM University. So she joined us from the first year, and we trained her completely right from the third year. She used to do around 8 to 9 projects basically, and we were able to place her in Amazon for around 24 lakhs. So just give your 100% effort. GUVI will be there to completely support you for the same. And one thing that I wanted to tell you here is you might be from any background, BPO, you might be working as a teacher. We've had teachers registering. We've had, people from working in BPO, people working in, like completely into electrical background, mechanical background, coming and taking it forward. So, you can start off from the scratch, attend the pre-boot camp, analyze yourself, what stage you are in. So whether we can place you or not, our team will discuss, and only then you'll step into the main program and taking it forward, guys, actually.